There we go. We got some folks in the room. Wait on a few more. What I just told the folks in the physical classroom is if you guys would go ahead and get out anything you did working on the performance final practice yesterday. That's what we're going to spend the bulk of our time on today, is going over that. Okay, so let's talk about performance finals, because this is your first one in high school. You will have one in every math class throughout high school, okay? And here's how it works. It's basically a quarter of your final exam is one way to think of it. The final exam overall for every class in math, with the possible exception of AP classes, they sometimes do something a little different, is 20%. Like overall, the final exam grade. Meaning the multiple choice part plus the performance final part. The multiple choice part is 15% of your overall grade. The performance final is 5% of your overall grade. Usually that means it's a little bit less than a test grade. Most semesters we end up having enough tests that tests count like 6-7% each. And so performance final is close to that, maybe a little bit less. Okay, so the performance final, ways to describe it, sometimes people like to think of it as a little bit like an exemplar that you did like in middle school, maybe even elementary. It's definitely explaining and showing everything. The process is what you're being graded on much more than the final answer. I like to think of it, I think the easiest way to think of it is that you are trying to explain to somebody whatever it is. It could be a concept, a mathematical concept. It could be how to do a problem. You're trying to explain that to somebody that's really just a pen pal. You can't talk to them. You can't video with them. They send you this problem and say, hey, I'm having trouble with this. Can you explain how to do it? And the only way you can help your pen pal in, Antarctica or something like that is in writing. And so you are sending it back to them with a complete explanation of how to do this topic or how this works or whatever, and doing whatever you can to make it very clear, which includes, if sometimes it's appropriate to add tables, sometimes it's appropriate to add graphs, sometimes an image, especially in geometry. An image is important. Labeling things clearly, being as methodical as you possibly can. First I would do this, that kind of thing. You're just trying to tutor them in writing. Okay? So that's kind of the gist. That's kind of what you're going for. Does not have to be, it's not like a 5-paragraph essay. It doesn't have to be like in paragraph form. Full sentences are encouraged. Okay? At least some full sentences. And you pretty much assume you have to explain everything. Like you don't just explain if the question says explain your answer. The whole thing, it's assumed to be you're explaining your answer. Okay? So let's look first off the first one you did yesterday, and I've got a blank one here somewhere, so let me dig for it. There it is. Looks like this. And I just want to go through this one together, and then we're going to talk about the rubric, okay? Because the performance final is really the only thing we have left. It's tomorrow, aside from the final exam that's the multiple choice final. So we're pretty much talk about the performance final, and then just everything else is review, okay? So this says Jeffrey is determining the height of a building. He takes advantage of a nearby fire hydrant and the shadows that are cast on the ground. Now, if you can print it out, it already has the pictures on it for you. If you can't print it out, I would at the very least draw a couple of triangles. Draw these triangles, not with a lot of detail. You don't have to draw a fire hydrant or whatever. But I would do the following. I would go, okay, Jeffrey is determining the height of the building. He takes advantage of a nearby fire hydrant and the shadows that are cast on the ground. So we got this building. This is what we want to find as the height. This is 25 feet. And this angle is Z degrees. And over here we have a fire hydrant. Also has an angle of Z degrees. This is 26 inches. And this is 17 inches. Okay, so I would either start with this, or if you're starting on your own paper, just start by drawing a little picture. My pocket is warm, indicating to me my phone is not on screensaver. Okay, determine the height of the building H. Round your answer to the nearest foot. Show your work and explain how you found your answer. Okay, the easiest way, and there's a couple of different ways to do it, and you're not wrong to do it one way over another way. Okay, this is another way I like to describe performance finals. Is it's like the ultimate partial credit. You can get most of the credit as like a partial credit. It's more about partial credit, so to speak, than it is about a final answer. Okay, so you can do it a totally different way than I do and still get just as much credit. So I think that the most efficient way to do this one is using similar triangles. And the reason that I know that they're similar triangles is because angle. I have an angle pair here, an angle pair here. So I'm going to say that. I'm going to say the two triangles are similar by AA because the right angles are congruent. And Z equals Z, however I want to say that. Basically, just to point out that I have two angle pairs. Okay, so I can use a proportion to find the missing side. And then I'm going to show what proportion I'm going to use. I can do H over 26 equals 25 over 17. I could also do H over 25, this over this equals this over this. Keep in mind, because of similarity, similar figures are proportional in terms of their lengths. So based on the definition of similarity, we just need them to be proportional. It doesn't matter if the units are the same or not. Okay, as long as these units are the same and these units are the same. If you look at what you got here, you've got H over 26, that's feet over inches equals feet over inches. So that's okay. We're still comparing the same types of things. All right, so you could do this proportion or another equivalent one. Then I solve by cross multiplying. So I get 17H equals 650. Divide both sides by 17. I think it's 38 point something maybe. Yep. So H is approximately 38.235. And it said round to the nearest foot. So I would say, or 38 feet. Okay. this sentence or this proportion or this equation is just as important to the answer as this is. Okay, the final answer is not any bigger than the rest of this in terms of importance. You can actually get the final answer or get the ultimate answer incorrect and still get most of your credit on these. Okay, now we're going to go ahead and do the next part. And again, if you wanted to, you could have done this differently. You could have used over here inverse tan to find z. And then once you know z, move it over here and use tan to find h. Okay, so that's a perfectly legitimate way to do it too. So this was A. And then on B, what is the value of z, the measure of the angle of elevation to the sun? Round your answer to the nearest degree. Show your work and explain your answer. So I'm going to just use the fire hydrant. Because I already knew these two sides. I would say because 26 is opposite from z and 17 is adjacent to z, I can write an equation, or let's say write a tangent equation. And I'm going to remind my reader that tan is equal to opposite over adjacent. So the tan of angle z is equal to 26 over 17. Then z is equal to the inverse tan of 26 over 17. And you could write a note over here. We use inverse when finding missing angles. You could even add we only use inverse when finding missing angles. Okay, so then I get z is approximately and I accidentally turned off my calculator. $56.82, or it says to the nearest degree, I believe. Yeah. 57 degrees. So that would be a complete answer to B. It's not the only way to completely answer B. There's not really another way to find the angle, but you could describe it differently, maybe, just a little bit. But you need all these elements. You need to say how come, you need to be able to answer your explanation needs to be able to answer any questions somebody might have, like, why did you decide to use tan? Well, because opposite and adjacent is tangent, and this is the opposite, and this is the adjacent. Maybe on my picture I can label that opposite, adjacent. How did you know use the inverse? Because we're trying to find the missing angle, that kind of thing. Okay. All right, so let's talk about the rubric. The rubric has three parts: the content, the communication, and the reasoning and problem solving. And this is the same rubric that will likely be used for every performance final you do throughout high school, except in AP classes, which are FREs, and it's a little bit different. Because these are the same, this is the same rubric that has been used since, I think, 98. It's not going anywhere. Okay, so it's basically three different categories on a scale of 1 to 6 each. So an 18 out of 18 would be full credit. 18 out of 18 is very hard to get. 18 out of 18 would be like you should be writing a textbook about this. Okay. The rest of it, there's a scale basically that helps us to translate. It's not like if you got 9 out of 18, you get a 50. It's higher than that. Okay. So like 17 out of 18 is like a high A, 16 out of 18 is like maybe like a 93, 94-ish, etc. Okay. So you're going for as many points as you can on this scale. You notice that content is only 1/3 of the grade. Okay. Communication ends up in some ways being a lot more than 1/3 of the grade though, because I can't grade your content well or your reasoning well unless you communicate it to me. So communication becomes very, very essential. Okay. So things we're looking for in communication. Is this person who you're trying to tutor, are they going to be able to understand your explanation? Do they understand what you did first? Do they understand why you're doing what you're doing? Is it clear? Is it well organized? Is it well laid out so that it's very obvious what you did first and what you did second, etc.? Are there pictures when needed? Have you labeled things if you're trying to refer to specific angles? Do you have them labeled so that we know which angle you're talking about? That kind of thing. So those things are in communication. Again, I don't know necessarily how well you understand the content unless you communicate well with me. So you need to. So for instance, let's look back at this original one, this A part. In my answer here, content that we're seeing is, I know what similarity means. I know that AA is a similarity postular theorem. I know that that means the sides are proportional. I know how to set up a proportion. I know that to solve a proportion, I'm going to cross multiply. So all of that is content. So yes, the answer is part of the content answer, or the content points, but it's only one little part of it. So even if you're not sure how to get the final answer, you still want to show that you know math that is related to the problem, and you can still get a lot of points for that. Okay, so you want to show what you know about this topic or problems like this. So for instance, on this one, let's say that I had accidentally put the 25 down here and the 26 up here. So everything after that would be wrong. But if the only thing I did was just flip-flop those, then I would still probably get a 5 out of 6 on content. Okay, and if I've communicated well, I could still get a 5 or a 6 out of 6 on communication. And reasoning, my reasoning is sound. I need to use a proportion because they're similar, etc. So you can still get almost all the marbles, even if you have an incorrect answer. Reasoning is the other one that depends also on your communication. It's even maybe a little bit more so, because I have no idea what you're thinking unless you tell me. Why did you decide to use tangent? What did you do first? Why did you take this approach? Why did you decide to set up a proportion? This is all sort of in the reasoning as well. So there's a lot of overlap between the different parts of the rubric, but most of it hinges on communication. Now, you don't necessarily want to write a whole novel. You want it to be, again, you're trying to sort of tutor someone. You don't want them to open your letter and be like, this is way too much. I'm so lost because there's just writing all over this page. So you want it to be, somewhat succinct, but still say everything that needs to be said. Okay? So that's how that works. Any questions so far? Okay, let's look at what you guys got for the other ones and how they compare to mine. Things that you might have wanted to make sure you said. On topic 2, congruent triangles. Let me just look at this here first. It says if triangle DEF is a translation of ABC, and it's not underlined, that was my underline. What is true about the various sides and angles of the triangles? Specifically, what parts of these two triangles are related and how are they related? Why? So big picture here, you're trying to get at the fact that a translation is an isometry. Okay, it's a rigid transformation. Therefore, it keeps the sizes the same. So these things are congruent and all their parts are congruent. That's what you have to say. Okay, but you want to make sure you actually say it specifically because you were asked to say it specifically. So here's how I would answer that one. Translation is an isometry, which means that it preserves or keeps everything about size. This means that the triangles are congruent. So, and then I named which angles are congruent and which sides are congruent because they asked me to be specific in doing that. The why is really what I started with here. So you might want to, as you're finishing up your answer, go back. Did I answer all these questions? What is true? Specifically, which parts? How are they related? And why? Because we performed an isometry, and isometries preserve size. Questions there? Okay, so on 2B, to me, 2A being the lead-in, I'm going to stick with transformations. Remember, one of the things we wanted to talk about, one of the reasons we talked about isometries separately was the point that they preserve size. So isometries always create congruent figures. Okay, whereas a dilation creates a similar figure. So if I want to prove two things are congruent, talking about how I can map one of them onto another using isometries is one way to do that. So that's how I chose to answer 2B. I think it's the most succinct way to answer 2B. So let's see if I can find where I answered this earlier today. So I'm not recreating the wheel. I may need to recreate the wheel. Reinvent, I'm sorry. Okay, here we go. You want to be specific. I named my coordinates. I found the coordinates and I listed them. And I pointed out, here's what happens when I go from L to C, from M to B, from K to A. And this is a reflection across the y-axis because that's what happens when you reflect across the y-axis. Maybe I want to be a little more clear and say, only the sign of X of the X value is changing. And that equals a reflection across the y-axis. Different ways I could put that. And so it's an isometry. Reflections are always isometries, which means the size does not change and these two triangles are congruent. So if I can tell you how to map one of them onto another by either an isometry or a series of isometries, then I can say they're congruent because size is preserved in an isometry. Number 2C, they're not congruent. Now, I chose to talk about, I didn't go into this one in detail. This is not a complete answer here. Just because I think we already did a pretty complete answer for 2B, and I think you get the gist. But I want to point out, another way you could do it is you could compare, like, what we just did, I could say, let's translate this, and if I translate this, Y would go right here, not up there. Okay, so there's not an isometry I can use to get from down here to up here. Another option is I could find all the side lengths of one of the triangles and then point out that the other triangle doesn't have any side lengths that match. I could find all the side lengths. Now, if I chose to do that up here, find all my side lengths, I would have to point out the side lengths are all congruent. That means by SSS, the triangles are congruent. Okay? So remember that SSS is a thing. So here, I wouldn't just do one pair of sides because the argument could be made. If I say, well, here's YZ, here's AC, they're not the same. The argument could be made, well, you didn't compare the right sides. So I would probably either triangle, find all three side lengths, and then find one side length of the other triangle and point out that it doesn't match any of those. So these triangles are not congruent. Or again, you could talk about it from the standpoint of transformations. Last but not least on this one, here's what I did for 2D. You can compare that to what you got. Now on this one, I would say my communication would not get full marks on this one. Okay. because it's kind of all over the place. I would be, if I was trying to get some better credit, if I was trying to get full credit here, I would probably take up more space and be a little bit more methodical and wordy. I would say, first, I can reflect the triangle GLD across the y-axis, and maybe as follows, and show what happens to the points or something like that. Then, if I translate it, blah, 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 blah. Any questions on that one? Okay, on the next one, this is a good example of where you might want to add something in. And you're more than welcome to do that, because your goal is to take this problem this person has sent you and show them how to do it. And whatever you need to do that, you should do. So for instance, if you look at this figure, it did not have all the numbers of all the angles labeled by number. So I decided it would be much easier for me to refer to things if I went ahead and pointed out that angle 3 is going to be the one that's x plus 7. Angle 4 is going to be the one that's 5x plus 35. And angle 7 is going to be the one that's 45 degrees, which is probably what they originally were. They just pasted those on top of them. So that's part of communication, is labeling things that you can talk about it. Different ways to do this. First time I did it, well, I'll come back to that way. I think the more efficient way to do it is, because angles 3 and 4 are a linear pair, they have to be supplementary. You got to say that before you set up the equation. Then that gives you the equation. And you say these two add up to 180. And then you find x. Can I do that here? Yeah. So x is 23. Then if x is 23, this would be 30. But these two have to be congruent for the lines to be parallel. And that's what this says. Then the measure of angle 3 is 30 degrees. But if m is parallel to n, corresponding angles must be congruent. But if measure of angle 3 is 30 and measure of angle 7 is 45 degrees, they are not. So the lines are not parallel. Okay. Questions there? Okay. So next, state the relationship between these angle pairs. Now, you might question, what does that mean? If you don't know which relationship they're talking about, give all the relationships you know. Okay. So for instance, 8 and 5, those are vertical angles. 1 and 6 has no particular relationship. Let's say that, particular relationship. 3 and 6 is same side interior or consecutive interior. No, it's not. Those are alternate interior. I'm sorry. Looked at the wrong one. Alternate interior. 1 and 8 are alternate exterior. And 5 and 1 are corresponding. Now, the other type of relationship we could be talking about here is everything here are congruent or supplementary if the lines are parallel. So is that what they're asking us about? Since we don't necessarily know that the lines are parallel, in fact, in that example up there, they're not, I would say if parallel, these are congruent, these are supplementary, these are congruent, these are congruent, and these are congruent. So I've pointed out there in terms of content that I know which ones are supposed to be congruent or supplementary if the lines are parallel. And I pointed out that I remember that that's only true if the lines are parallel. So by doing this, I've given you a lot more, hey, look, I know this too. And that's what you're trying to do here. State the relationship between angles 3 and 5. Okay, would this be enough information to prove that line M is parallel to line N? Again, this is not the best question. So in terms of how should I answer this, I'm just going to give all information that might apply. Okay, I could say, well, I know that 3 and 5 are same side interior angles. They didn't tell me anything about 5. So I could go in next into saying that if 5 and 7 are a linear pair. So then if 7 is 45, 5 would have to be 135. Or I could just say, I could point out what would be enough information because they didn't give me much. I could say, in order to know M is parallel to N, I would have to know angle 3 and angle 5 are supplementary. So x plus 7 plus measure of angle 5 would equal 180. And maybe I would say from what we know that doesn't appear to be the case. Something like that. From the info above, that is not true. Something like that. Okay. Questions on this one at all? Okay, here's what I said on the last one. Okay. Rigid motion is a motion that preserves size. The 3 types of rigid motion are rotations, reflections, and translations. And then it tells me plot the image of the triangle after the transformation, blah, blah, blah. Now notice that I showed my coordinates. You want to do that. We could show it visually. We can also show it in terms of coordinates. So I'm going to do both. Because what if my friend understands it better like this than on the graph? Whatever. I'm trying to explain it and show it as well as I can. This is a dilation, which does not preserve size. ABC is not congruent to A prime, B prime, C prime, so it is not a rigid motion. I could add, if I wanted to, that actually those will be similar triangles, not congruent. Okay. Next. It's a reflection across the y-axis. We actually already dealt with one of these. When the sign of x is the only thing that changes, that's what you're doing, is reflecting across the y-axis. The triangles are congruent, and it is a rigid motion. You also could have used, if you wanted to, you could use distance formula to find all 3 sides and show that because all 3 sides are the same, by side, 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 they are congruent triangles. It's a little bit more work, but you could. Okay, so overall, I just wanted to go ahead and show you what I might put, give you an idea compared to what you might have put yesterday looking at this, and also talk about what your performance finals are like, and that's what we've done. So let's talk about the 2 other things you needed to get out of yesterday. One is you should have submitted that construction worksheet, which is basically just recreating the 9 constructions that we did Thursday and Friday. Okay, you could have submitted it on yesterday, on the Google Classroom for yesterday, on the Google, the classwork assignment page, or you could do it on today if you need to, if you still need to submit it or whatever, that's fine. I think one person emailed it to me. If you submitted it someplace other than that, please let me know. So that was yesterday. You need to submit that. Also, I gave you a Delta Math that is an overall review of the semester that I asked you to go ahead and start on. That's really your only homework for today, is to really continue working on that, because by reviewing that, you're reviewing for the performance final and for the final exam, because they're both pretty much just cumulative from the semester. So any questions before I let go of you? I feel like I'm holding you captive. Are you talking about this particular problem, or just go back over what's true with parallel lines? I'm confused. Or do you mean like on the format plane?
On the practice sheet yesterday, where you did the constructions, I was having some trouble on the parallel lines.
Oh,
Besides,
constructing a line. Okay,
yeah.
so constructing a line, this one right here, constructing a line parallel to another line that goes through a particular point.
Yes.
Sure. Okay, so let me start with a line and a point that's not on the line. So I'm going to just do random weird one and a point that is not on my line. Okay. So I have a line, I have a point that's not on the line. Here it is. Okay, so the instructions say draw a line through A that crosses CD at an angle. So basically you're drawing a line that goes through your point that crosses this other line, but is not perpendicular to it. So I'm going to draw like maybe this. It's basically like you're drawing a transversal between your two perpendicular parallel lines. Like you're expecting this line to be parallel to the other one, and you just drew a transversal. And then what you're going to do now is you're going to create two angles that are congruent and are corresponding. And that way you'll know that this line is parallel. So first step there is, it says open your compass to be about half the distance between these. That's not necessarily exact, but there we go. I need less paper. Keep your compass open the same exact distance and move the tip from down here to that point that's not on the line. And then you do the same arc. Now, it should cross the line you drew. So when it doesn't, you can just extend that line. So those are my corresponding angles, basically. Okay. Next step is to measure this by opening the compass about that width. Okay. And I'm going to take that measurement, basically. That's how we measure with a compass. We open it so that the pencil tip and the metal tip are on either end of that arc. And I'm going to move it up here and draw an arc in the same position on this arc. And this point is what I'm going to draw my parallel line through. And there it is. Remember, too, that I posted on Thursday and Friday. I guess this was on Friday. On Friday's page, let me just double check that I'm not lying to you. Yeah, on Friday's page, there is a YouTube video of me doing every one of these day 2 constructions. So if you want to watch it and just pause it as you go, that might help. Or use the one that is in the QR code.
Thank you so much. That helps.
Yeah, good. No problem. This is probably the hardest one. I could totally see that. It's the one I get the most questions about. Any other questions? Let me just make sure digitally the people that I thought weren't here didn't come in. Got Michaela, you came in. The Angelina's not here. I don't know why, Alex. I marked you absent. I'm so glad I looked at that again. Yeah, Bets. And Emily Skillen, I'm not seeing. All right. Okay, so work on that Delta math, and tomorrow we'll do the performance final. It's going to be, like I said, if you can print it, you can, but you can also just do it on paper. And then a lot of times when I do it in a classroom, my students end up wanting to do it on their own paper anyway, and I give them extra paper to go onto too. So it's not a big deal to just do it on paper. Blank paper, lined paper, I would probably use lined paper if I were you. And then you're going to submit it just the same way you did the constructions from yesterday in terms of a PDF is fine, a Google Doc is fine, however works best for you. Okay, so let me know if you have any questions about that. And I will see you guys tomorrow. You do need to log in. It's like a test, so you do need to log in, folks at home. Bye.